Good evening, everybody. Hope all of you are fine. Today, our next important topic, that is, yeah, everything fine. I hope you can see the board clearly. Today, I am going to give you one very important, very important topic, that is trigonometric ratios in different quadrants. So, how trigonometric ratios will change when you change from one quadrant to another quadrant. You have idea about coordinate geometry. In coordinate geometry, we'll be having quadrant 1, quadrant 2, quadrant 3, quadrant 4. X-axis and y-axis divides the plane into 4 quadrants. Okay, between quadrant, hope you have idea already, quadrant 1, 2, 3, 4. Now, how these trigonometric ratios we have seen in 10th class, we have sine theta, cos theta, tan theta, cosec theta, secant theta, and cot theta. These 6 trigonometric ratios, how they vary, how they will be different in different quadrants, that we are going to discuss today. So before we are going to discuss about it, yeah, all of you, hi all of you, hope you all are fine. Now I think now you are joining. Okay. Now first, before you are going to this topic, you have to know different ways of representation of angle. Different ways of representation of angle. We know as of now degrees. What we have seen, 0 degrees, 60 degrees, 30 degrees, 45 degrees, like 90 degrees. We have know this. Now we are going to know this is in what degrees. Before we are going to that topic, you have to know another way of representation of angle, that is radians. This is new to you. Okay. Now, we will discuss about the different representation of angles first to understand about all silver teacups or different trigonometric ratios in different quadrants. Now, radians is one type of measurement of angle. Okay, degrees is another type of measurement of angle. As of now, we are using degrees. Now we are going to know how do we represent an angle in terms of radians. The difference here it is 180 degrees is equal to pi radians. As of now, we know pi is equal to 22 by 7. Pi will be used to represent when that 22 by 7. We take pi value as 22 by 7. Now, this is another way of uh, utilization of pi. Here in rad to use to express angle also we use pi. Here pi means what? Pi is equal to 180 degrees. This is another value of pi. Now onwards you have to remember it. Pi is 1 pi is equal to 180 degrees. Okay. So if pi is 180 degrees, what is pi by 2? You know, pi by 2 means what? 180 by 2, which is 90 degrees. Pi by 2 is 180 degrees. What is pi by 3? Pi by 3 means what? Pi by 3 will be what? 180 degrees by 3, which is 60 degrees. Pi by 4. Pi by 4 means 180 degrees by 4. What it is? 45 degrees. After cancellation, we get 45 degrees. So you have to know pi is equal to 180 degrees. Pi by 2 is 90 degrees. Pi by 3 is 60 degrees. Pi by 4 is 45 degrees. Pi by 6. Pi by 6 is 180 by 6 is what? 30 degrees. After cancellation, we get 30 degrees. Pi by 6 is 30 degrees. So, this is the way of representation of angles, degrees and radians. Now onwards, we are going to use radian system. Angles we represent in terms of radian. Instead of writing sine 60 degrees, we will be having sine pi by 3. Somewhere if it comes pi by 3, you will understand it is nothing but sine 60 degrees only. In another way, sine 60 degrees is represented in the form of sine pi by 3. Cos 60 degrees, cos pi by 3. Sine 90 degrees, sine pi by 2. If it is there somewhere, what you have to understand it is sine 90 degrees. Hope you understood the representation of angle in radians. Now, let us enter into our topic, that is what are the different quadrants we have and how trigonometric ratios will be different in different trigonometric different quadrants. This is our plane. Now here, this is what we start from 0 degrees. Okay, from here we start, angle is 0 degrees, and when you come from here to here, what is this angle? From here to here, how much angle it is? From here to here it is exactly 90 degrees. So when you come from here to here, it is what? 90 degrees. So what you should understand, if angle is from 0 degrees to 90 degrees, whatever angle it is there between 0 to 90 degrees, that will be belonging to quadrant 1. 0 degrees to 90 degrees will be belonging to quadrant 1. Means what? All the angles between 0 degrees and 90 degrees will be there in quadrant 1. 0 degrees to 90 degrees, it is quadrant 1. Now 90 degrees, from here to here, 90 degrees to again, this is what? From up to here 90, from here to here again it is 90 to one more 90. When you add one more 90, how much it is? 180 degrees. So what it is? 90 degrees to 180 degrees. Whenever an angle is between 90 degrees to 180 degrees, you have to understand that is there in quadrant 2. If angle is from 90 degrees to 180 degrees, that is quadrant 2. Now 180 degrees to next 90 degrees. 180 degrees to what it is? 270 degrees. 180 degrees to 270 degrees, what it is? Quadrant 3. Next 270 to 360. 270 to 360 degrees is quadrant 4. So like this. If somewhere if I have given 45 degrees, where it lies? 45 degrees lies in quadrant 1. 60 degrees lies in quadrant 1. 30 degrees lies in quadrant 1. Suppose if I give you 120 degrees, where that angle 120 degrees lies? Can anyone answer? 120 degrees, in which quadrant it lies? 120 degrees is between 90 degrees and 180 degrees. So it lies in quadrant 2. You have to remember it. If I give you 225 degrees, some angle I have given 225 degrees. 225 degrees lies in quadrant 3. 225 degrees lies in quadrant 3. 300 degrees. If I ask you 300 degrees, 300 degrees lies in quadrant 4. This is one very important point. After that, the same 0 degrees, 90 degrees, 180 degrees, 270 degrees and 360 degrees, we can also express in radians. Just now I told you how angles will be expressed in terms of radians also. 0 degrees is 0 degrees itself, but 90 degrees can also be written it as pi by 2 in radian system. So 0 to pi by 2, 0 degrees to pi by 2, it is quadrant 1. Here pi by, this is what? 180 degrees means what? Pi. 180 degrees is what? Pi. So what? Pi by 2 to pi. If angle is there, pi by 2 to pi, it lies in quadrant 2. Now this is pi, but what about 270 degrees? 270 degrees in quadrant radian system, how do we express? When you want to express 270 degrees in radians, you just multiply 270 into pi by 180. 0, 0, 9 threes are 9 twos are. So what it is 3 pi by 2. When you want to express any angle from degrees to radians, just you need to multiply pi by 180 to that angle. So 270 into what? Pi by 180. 270 into pi by 180 is 3 pi by 2. So what is 270 degrees? 3 pi by 2. So this is 3 pi by 2. So this is pi, this is 3 pi by 2. So if angle is between pi to 3 pi by 2, it will be there in quadrant 3. 3 pi by 2, this is what? Exactly 2 pi. 180 degrees. Pi is 180 degrees, 360 degrees is 2 pi. So angle is between 3 pi by 2 to 2 pi. It is there in fourth quadrant. So quadrant 1, quadrant 2, quadrant 3, quadrant 4. These are what? Angle range. Which angle to which angle in which quadrant it lies. Hope up to here clear. What I said now, 0 degrees to 90 degrees, quadrant 1, 90 degrees to 180 degrees, quadrant 2, 180 degrees to 270 degrees, quadrant 3, 270 degrees to 360 degrees, quadrant 4. Same thing in terms of radians, 0 degrees to pi by 2 radians. Same angle, 90 degrees is nothing but pi by 2. That's why 0 degrees to pi by 2 radians, 0 radians to pi by 2 radians, quadrant 1, pi by 2 to pi, that is 90 to 180, pi by 2 to pi, second quadrant, pi to 3 pi by 2, pi to 3 pi by 2, third quadrant, 3 pi by 2 to 2 pi, fourth quadrant. Up to here, hope everybody are clear how to identify which angle lies in which quadrant. This is important first. When you have some angle, you should know that angle is present in which quadrant. Is it in quadrant 1, quadrant 2, quadrant 3, quadrant 4? I have given that clarity, which angle to which angle, in which quadrant it lies. Now coming to our trigonometric ratios, here some trigonometric ratios will be positive in some quadrants and they will be negative in some other quadrants. Now we are going to know which trigonometric ratio is positive in which quadrant. We have 6 trigonometric ratios: sin theta, cos theta, tan theta, cosec theta, secant theta, cot theta. Now we are going to know which trigonometric ratios are positive in which quadrant. Now to remember it, we have a sentence. Hope many of you have listened already about this sentence. That is all I am writing up. Hope you all can see here. This is what? All silver all silver teacups. You have to remember this sentence. If you remember this sentence will give you idea in which trigonometric ratio, in which quadrant it is positive. Which trigonometric ratio is positive in which quadrant. So this word, first word all, we take in quadrant 1. First word we write it in quadrant 1. So here what we have to write in quadrant 1? All. Quadrant 1. And the second word, silver, this should be taken in quadrant 2. So here what we should write? Silver. This word T is in quadrant 3. So here we have to write T. This word cups will be there in quadrant 4. We have to write that in quadrant 4. Here it is cups. So we have 4 words. First word in quadrant 1, second word in quadrant 2, third word in quadrant 3, fourth word quadrant 4. All silver, tea, cups. Now let us see what this all indicates. All indicates all the trigonometric ratios. What all trigonometric ratios we have? Six trigonometric ratios we have. Sin theta, cos theta, tan theta, cosec theta, secant theta, and cot theta. Like the six trigonometric ratios are there. All these six trigonometric ratios are positive in quadrant 1. In quadrant 1, all are positive. That's why we write here all in the first quadrant. Now coming to second quadrant, we have silver. In the silver, you take these two, we have SI. What that SI indicates? A trigonometric ratio which starts with SI. Which trigonometric ratio starts with SI? Clearly sine. So what here? Sine will be positive. Sine theta will be positive. And what is its reciprocal? Sine theta is positive and its reciprocal is cosec theta. Only these two are positive. In quadrant 2, sine theta and its reciprocal cosec theta. Only these two are positive in quadrant 2. Hope you understood this. That's why we take the word silver which starts with SI. So by this word silver, SI, sin theta and its reciprocal cosec theta are positive in quadrant 2. That you have to remember. Now coming to third quadrant, it is T. First letter T you take. What this T indicates? The trigonometric ratio which starts with T. We have tan. Tan starts with T. So what are positive in third quadrant? Tan theta and its reciprocal cot theta are positive in quadrant 3. Tan theta and its reciprocal cot theta are positive in quadrant 3. This you have to remember. Now coming to fourth quadrant, we have C. And what are the trigonometric ratios that are left? Sin theta and cosec theta are over. Tan theta and cot theta are also over. Then the remaining two trigonometric ratios are cos theta and secant theta. Here we have C. Why C indicate here? What C indicates? Not cot or cosec, because already cot and cosec we have taken. Remaining is what? Cos. So here cos theta and its reciprocal secant theta are positive in quadrant 4. So in first quadrant, all six trigonometric ratios are positive. Second quadrant, silver means sin theta and its reciprocal cosec theta are positive. Third quadrant, T, word is T. The T indicates tan theta and its reciprocal is cot theta. Tan theta and cot theta are positive in third quadrant. Now fourth quadrant, we have C. C is what? Cos theta and secant theta are positive in fourth quadrant. Hope all of you are fine up to here. Try to watch the video till the end. You will be having clear idea about this concept. Up to here, hope all of you have understood. First quadrant, second quadrant, third quadrant, fourth quadrant. Now, how this concept we apply? Let's go to the next page to understand about this. So, first I told you angle. Which angle lies in which quadrant? That you have to remember. 0 to 90 first quadrant, 90 to 180 second quadrant, 180 to 270 third quadrant, 270 to 360 fourth quadrant. First you have to remember that, and after that in which trigonometric ratio is positive in which quadrant, that also you have to remember. After these two, you have to remember one more, that is this concept n pi by 2 plus theta. N pi by 2 plus theta. Whenever angle is there in this format, n pi by 2 plus theta, if n is odd in this representation, if n is odd, what happens? If n is odd, what happens? Sin theta will be changed as cos theta and cos theta will be changed as sin theta. They both will be changed. Similarly, tan theta will be changed as cot theta and cot theta will be changed as tan theta. One more, secant theta will be changed as cosec theta and cosec theta will be changed as secant theta. I will tell you one small example to understand better. For example, I have somewhere sine 120 degrees. I want the value of sine 120 degrees. Then what can we write sine 120 degrees? You know, sine of 90 degrees plus 20 degrees, not 20 degrees, 90 degrees plus 30 degrees. We can write it as sine 90 degrees plus 30 degrees. Now 90 plus, do you remember how we have drawn quadrants? This is what 0 to 90. This is 90 to 180. So 90 to 180, 120 is in which quadrant? I told you 120 degrees. When it is 120 degrees, it is between 90 and 180. 120 is between 90 and 180. In which quadrant it lies? Second quadrant. Then you have to go for all silver teacups. Once you decided angle is in second quadrant sine is positive or negative, you have to identify. All silver in second quadrant, silver. Silver means sine and cosecant are positive. Means sine is positive. And now whether the sign will be changed or it will be as usual, we have to decide. Now sine 90 means what? Pi by 2. 90 is what? Pi by 2 plus 30 degrees. 30 degrees. So pi by 2 plus 30 degrees. Or you can also remember this if you have any confusion here. You can also remember n into 90 degrees plus theta. Okay, this n, if the n is odd number, it will be changed. Suppose if n is even, I did not tell you this. If n is even, the sign remains sign. There will be no change. Cos remains cos, tan remains tan, cosec remains cosec, remains, that ratio remains as usual. There will be no change. If this n multiple of 90 degrees, if multiple of 90 degrees is even, there will be no change in the ratio. If multiple of 90 degrees is odd, then the ratio will be changed, interchanged. So that you have to keep in mind. Now it is what? 90 degrees, we have 90 plus 30 degrees. Means what? It is 1 into 90. 1 is what? Odd number. When odd number is there, I said it should be changed. If n is odd number, it should be changed. The sign should be changed as cos. So what it will become? Cos. Sin 90 plus theta will become cos theta, cos 30 degrees. So the answer is what? Cos 30 degrees is root 3 by 2. Answer is root 3 by 2. So what is sin 120 degrees? Sin 120 degrees is root 3 by 2. Maybe still you are in some confusion. Let us write some results. After we are writing some results, you will be having clear idea. Watch the video till the end. You will be having complete idea about it. Now let us write some results so that you will be having complete idea. I am writing first sin 90 minus theta, cos 90 minus theta, tan of 90 minus theta, cosecant of 90 minus theta, next secant of 90 minus theta, cot of 90 minus theta. Okay, similarly, here I am writing again sin of 90 plus theta, cos of 90 plus theta, tan of 90 plus theta. We have to write all the results, all these results. Cosecant of 90 plus theta, secant of 90 plus theta, cot of 90 plus theta. Now let us see what are the results. Everywhere pi by 2 or 90 degrees multiple is 1 here. 1 into 90 we have. When 1 into 90 is there, odd, n is odd here. In all these 12 changes, n is odd. When n is odd, a ratio will be changed. I said ratio will be changed. That is one point you have to remember. And one more point, 90 minus. 90 minus means whenever it is minus, you have to come in anti-clockwise direction. 0 plus, if it is there somewhere 0 plus, first quadrant. If you have somewhere 90 minus, from 90 you will come in backward direction. When you are coming from 90 minus, it will be there in quadrant 1. When you are having 90 plus, if it is 90 plus, you are coming into second quadrant, quadrant 2. If it is 90 plus, quadrant 2, 90 minus, quadrant 1. Similarly, if you have 180 plus, quadrant 3, 180 minus, quadrant 2, 270 plus, quadrant 4, 270 minus, quadrant 3, 0 minus, quadrant 4, 0 plus, quadrant 1. So you have to understand that is in which quadrant also. Now all these 90 minus, 90 minus, 90 minus means which quadrant? All these lies in Q1. And in Q1 we know all are positive. So all the results will be positive. There is no confusion. 90 minus, when you have, all the results are positive. That is okay. And because n is odd, all the trigonometric ratios will be interchanged. So by these two, what we can write? Sine will become it as cos, and it is positive because it is in quadrant 1. So the result is just cos theta. Similarly, cos 90 minus theta is there. Cos 90 minus theta will be, ratio will be changed and it is positive, sin theta only. Tan 90 minus theta is cot theta. Cosecant 90 minus theta is secant theta. Secant 90 minus theta is cosec theta. Tan 90 cot 90 minus theta is tan theta. Because why we have written like this? Because when n is odd, trigonometric ratio will be changed, and because it is in quadrant 1, all are positive. Coming to this, here also n is odd, so trigonometric ratio will be changed. N is odd, trigonometric ratio is changed, but it is in second quadrant now. And 90 plus, when you are having 90 plus, it is in second quadrant now. In second quadrant, all are not positive. Only sine is positive. One more, its reciprocal cosecant is positive, and the remaining all are negative. And I told because it is odd, it will be changed. So 90 plus theta will be what? Cos theta. Sin 90 plus theta is cos theta because it will be changed. Now cos 90 plus theta, it is sin theta, but cos theta is negative in the second quadrant. I told only sin theta and cosecant theta are positive, remaining all are negative. Because it is cos 90 plus theta, your result will be minus sin theta. Result is minus sin theta. Similarly, tan 90 plus theta, here also what happens? Minus cot theta, because odd it is there, odd number it is there, 90 multiple is odd number, so minus cot theta. Cosec 90 plus theta, because it is cosec and second quadrant. In second quadrant, cosecant is positive, that's why it is plus secant theta, because cosecant will be changed as secant. Now secant 90 plus theta, secant is negative in the second quadrant, so minus, because it is 90, it is cosec theta, and here minus tan theta, because in second quadrant cot is negative. So what are positive in second quadrant? Sin theta, so sin 90 plus theta is plus cos theta, and one more, cosec 90 plus theta is plus secant theta, but remaining all are negative. I will tell you how these all will be useful later, but I am telling you how to identify. In first quadrant all are positive, but in second quadrant like this. Now let us see one more. Now I told 90 minus 90 plus. Now let us see 180 minus 180 plus, how the ratios will be different. Sine 180 minus theta, cos of 180 minus theta, tan of 180 minus theta, cosecant of 180 minus theta, secant of 180 minus theta, cot of 180 minus theta. Similarly again, sine of 180 plus theta, cos of 180 plus theta, tan of 180 plus theta, cosecant of 180 plus theta, secant of 180 plus theta, cot of 180 plus theta. Now what you have to know again, what you have to identify first? First thing we have to identify in which quadrant it is. Again, roughly if you draw here, 0, 90, 180, 270, 360. 180 minus, you should go in backward direction, 180 minus, quadrant 2, 180 plus, quadrant 3. So, these all lies in quadrant 3, these all are lying in quadrant 2. So, that you have to remember, 180 minus theta is in quadrant 2. This is one point you have to know. And one more what we have to know, 180 degrees is 2 into 90. 2 into 90 degrees means what is the multiple of 90 degrees here? Even number. Multiple of 90 degrees is even. When multiple of 90 degrees is odd, it will be interchanged. But when multiple of 90 degrees is even, there will be no change in the ratio. So what happens here? The result will be there in same terms like sine only. And in second quadrant, sine is positive. Which are positive in second quadrant again? 180 minus theta lies in second quadrant. In second quadrant, only sine and cosecant are positive, remaining all are negative. And because it is even, multiple of 90 degrees is even, the result is going to be plus sine theta. Sine theta remains same, sine theta only. Why it is not changed? Because it is even multiple of 90 degrees. So second, it is cos theta, but in second quadrant, cos theta is negative. That's why it is minus cos theta. Cos 180 minus theta is minus cos theta. Tan 180 minus theta is minus tan theta. Cosecant 180 minus theta is plus cosecant theta. Next, secant 180 minus theta is minus secant theta because it is negative in second quadrant. Cot is minus cot theta. Why the ratios are remaining same? Because we have 2 into 90 degrees, where 2 is an even number. If multiple of 90 degrees is even number, it will not change, ratio will not change. Can you hear me? Right, okay. Right, now hope you understood this part. Now let us see the next part. It is 180 plus theta. 180 plus theta is in which quadrant? 180 plus theta is in third quadrant. So here all these we have to check in quadrant 3 how they will be, whether they will be changed, they will be negative or positive, first thing. And one more thing, again here also we have 2 into 90. 2 into 180 can be expressed as 2 into 90 means what? It is even multiple of 90 degrees. When it is even multiple of 90 degrees, ratio remains same. Okay. So in third quadrant, because all these are in third quadrant, which ratios are positive? Third quadrant is T. T means for tan and its reciprocal cot. Only tan and cot are positive. Remaining all are negative. And because it is even multiple of 90 degrees, trigonometric ratio will not change. It will be as usual. Means what? The ratio here it is minus sine theta because it is in third quadrant, it is minus sine theta. So sine of 180 plus theta is minus sine theta. Cos of 180 plus theta is minus cos theta. Tan of 180 plus theta is plus tan theta because it is in third quadrant. For example, cosecant of 180 plus theta minus cosec theta. Secant of 180 plus theta minus secant theta. Cot of 180 plus theta minus, oh, it is plus cot theta. I will tell you one example how it will be useful. For example, you have somewhere tan 225 degrees. We have to find the value of tan 225 degrees. How can we write it? We can write it as tan of 180 degrees plus 45 degrees. 225 degrees can be written as 180 plus 45 degrees. Just now I told you tan of 180 plus theta is tan theta. So it is what tan of 180 plus 45. So we can write it as tan 45. What is tan 45 degrees? 1. So tan 225 degrees is also 1. So we can find out like this. These are applications. Okay. Hope you all understood how it is useful, this concept. Now we have seen 180 minus theta, 180 plus theta. Now let us see in the same way 270 minus theta, 270 plus theta. Problems we'll discuss later in next class. But today try to understand in which quadrant, which trigonometric ratio, how it will be changed. So next 270 minus theta, 270 plus theta. Sine of 270 degrees minus theta, cos of 270 degrees minus theta, tan of 270 degrees minus theta, cosecant of 270 degrees minus theta, secant of 270 degrees minus theta, then cot of 270 degrees minus theta. This is 270 degrees minus. Next, let us write 270 degrees plus theta. Sine of 270 degrees plus theta, cos of 270 degrees plus theta, tan of 270 degrees plus theta, cosecant of 270 degrees plus theta, secant of 270 degrees plus theta, at last cot of 270 degrees plus theta. Now let us write the results. 270 minus, 270 minus, which quadrant? 270 minus, this is 270, this is 0, this is 90, this is 180, and after completing rotation it is 360. So 270 minus, 270 minus is Q3, 270 plus is Q4. So this, all these are lying in Q3, all these are lying in Q4. This is one thing you have to know, and another thing we have to know, 270 is 3 into 90 degrees. 270 is 3 into 90 degrees. Means what? Multiple of 90 degrees is odd number. When multiple of 90 degrees is odd number, all the trigonometric ratios will be changed. Sine will be cos, cos will be sine, like that. So here sine, and one more thing, Q3, no, in Q3 which are positive again? Tan is positive, cot is positive. Okay, so what we can write it as, sine will be changed as cos, so minus cos theta it is. This is minus sin theta because it is in Q3, sine and cos are negative, and because it is 270 degrees odd multiple of 90, sine will be changed as cos, cos will be changed as sine. These two should be there in mind. Multiple of 90 degrees should be there in the mind, and next angle is in which quadrant you should keep in mind. 270 minus theta, it is third quadrant and it is cot theta now. And here cosecant 270 minus theta minus secant theta. Secant 90 minus theta or 270 minus theta minus cosecant theta. This is plus tan theta. I told you just now tan 225 degrees. How can we find? We can also find this by writing like this, tan 270 degrees minus 45 degrees, because 225 degrees can also be written as 270 minus 45. It can be written 180 plus 45 or 270 minus 45. 270 minus 45, which quadrant? It is looking like this. So what it is? Plus cot theta. So plus cot 45 degrees. Plus cot 45 degrees is also plus cot 45 degrees is also 1. Before we got 1, now also we got 1. So in any way you can find out. So see this here, what happens? All 270 plus theta. 270 plus theta is in fourth quadrant. In fourth quadrant, which are positive? In fourth quadrant, cups. Last word is cup. So cups means cos theta and its reciprocal secant theta are positive. Remaining all are negative. So, and here it will be changed. The ratio will be changed. So sign will be changed as minus cos theta. And this is what? Plus sin theta, because cos is positive in fourth quadrant. And tan 270 plus theta minus cot theta. This one, cosecant 270 plus theta, cosecant is negative, so minus secant theta. Secant is positive, that's why it is plus cosecant theta. Next, cot 270 plus theta. How it is? Minus tan theta, because it will be changed. I will tell you one example here. Suppose I have sine 300 degrees. I have to find sine 300 degrees. How can I find sine 300 degrees? I can write it as sine of 270 degrees plus 30 degrees. I can write it as sine of 270 degrees plus 30 degrees. It is looking like sine 270 plus theta. What is sine 270 plus theta? Because it is in fourth quadrant, negative, and because it is odd multiple of 90, cos will come. So minus cos 30 degrees it is. Now we all know what is cos 30 degrees value. Cos 30 degrees value is root 3 by 2. So the result is what? Minus root 3 by 2. So what is the value of sine 300 degrees? Minus root 3 by 2. So like this it will be useful. If you know how the ratio will be changed according to the quadrant, you can find out the values like this. Now at last, this is one more at last. We will discuss 360 minus theta and 360 plus theta. Then we conclude today, and in tomorrow's class, some simple problems based on, I told you one or two problems now, how this concept will be used. We will discuss some problems based on this concept. Now at last, let us see 360 minus theta and 360 plus theta, how it will be changed. You try to answer. I will write here questions. You try to answer it. First, all minus sine of 360 degrees minus theta, cos of 360 degrees minus theta, tan of 360 degrees minus theta, cosecant of 360 degrees minus theta, secant of 360 degrees minus theta, cot of 360 degrees minus theta. Similarly, plus also let us write sine of 360 plus theta, cos of 360 plus theta, tan of 360 plus theta, cosecant of 360 plus theta, secant of 360 plus theta, cot of 360 plus theta. So here, because it is 360 minus, which quadrant you have to decide first? 0, 90, 180, 270, 360. Minus means you have to come in reverse direction. Plus you have to go in forward direction. So 360 minus theta will come in quadrant 3. 360 plus theta will come in quadrant 4. And because 360 can be written as 4 into 90 degrees. 4 into 90 degrees, 4 is what? Even number. So there will be no change in the trigonometric ratio. So here what are positive here in third quadrant? Tan and cot. Remaining all are negative. So here minus, because it is even number, minus sine theta. Again this is also negative, so minus sine theta. Minus cos theta, because ratio will not change. Minus cos theta. But here it is plus tan theta, because it is positive in third quadrant. This is minus cosec theta. This is this is minus secant theta. This is minus plus cot theta. It is not minus because in third quadrant it is plus cot theta. Now coming to this side, 360 plus theta. 360 plus theta means it will be there in first quadrant. In first quadrant all are positive and ratio will not be changed. So the results are sine theta, cos theta, tan theta, cosec theta, secant theta, cot theta. So like this, results will be there. We will discuss applications or problems based on these concepts in tomorrow's class. So somewhat I tried to make you to understand these concepts. Tomorrow, if you discuss problems, you will understand more better. Try to attend tomorrow's class also and share this link to your friends. Let them understand this concept. Thank you.